Well, the other day we talked about multiplying and dividing fractions. Today we're going to talk about adding and subtracting fractions. What do you know about adding and subtracting fractions? They have to have a common denominator. All right, so if I gave you 3/8 plus 5/6, you'd have to find a common denominator and get those denominators to be the same value. Okay, so what's a common denominator? 48 is a common denominator, but 24 is a better one. Why is 24 a better one? It's smaller. You want to try to keep your denominators as small as possible. So 48 would work. It's just if you use 48 later on, you'd have to reduce your fraction. Not a problem. So I would definitely go with 24. So if I change the bottoms, I also have to change the tops. So how did I change an 8 into a 24? I multiplied by 3. So if I multiply the bottom by 3, I have to multiply the top by 3. So that means the top is 9. And then I went from a 6 to a 24, so I multiplied by 4. So I need to do that on top. 5 times 4 is 20. And now that I have the same denominators, how do I add? Add the tops, and what do I do to the bottoms? Nothing. It's the same. 29 over 24. That's an improper fraction, meaning the top is bigger than the bottom. Improper fractions are perfectly fine by me. Some people are fanatic about converting to mixed numbers. If you want to convert to mixed numbers, convert to mixed numbers. I don't care. I'm perfectly happy with that answer. So I would leave it just like that. You could write it as 1 and 5/24, I guess. And we'll see that in a minute here. That doesn't really make much sense for what we're going to do anyway. So what if we had 3x over 4 plus 2x minus 1 over 6? Same deal. The fact that we have x's there doesn't change anything. We still need a common denominator to add those fractions. Common denominator this time is 12. All right. So this first fraction, I multiplied the bottom by 3, so I better multiply the top by 3. So 9x. Second fraction, I had to multiply the bottom by 2, so I better multiply this one by 2. And distribute it through is a very good idea, correct. 4x minus 2. Alright, and then nothing changes. The bottom stays the same, and I add the tops. 9x and 4x makes 13x minus 2. Alright, no problem so far, right? They're not going to get bigger, really. What they're going to get is xier. So what I mean by that is, what if I change it to 4 over 3x plus 9 over 2? Okay, you want 2? We'll do 2. Correct. So we have to get a common thing. So we look at the numbers for a 2 and a 3. The common denominator is 6, but this one needs an x on bottom, which means I need to put an x on bottom of that one. So our common denominator is going to be 6x. Alright, so how did I turn a 3x into a 6x? I multiplied by 2, so the top gets multiplied by 2, that becomes an 8. How did I turn a 2 into a 6x? Multiplied by 3x, so I have to multiply by 3x on top, 27x. And then there's not a whole lot I can do here. I'm going to write this as, well, this x could cross out with that x, that's true, but then I wouldn't have a common denominator anymore. You do, to add your fractions. 27x plus 8 over 6x, and that's really the best I can do. I really can't simplify that at all. Questions on that one? Oh, you want more complicated ones. Why not? Because I'm going to do it anyway. I mean, all right, you want harder ones? We'll do harder ones. 5x over x minus 2 plus 27x over x plus 3. All right. So this time, what do you got for a common denominator? X plus 6? If I multiply the first one by a negative 3, that gives me negative 3x plus 6. Yes. All right, so it's just like back on this very first problem, where I was told the least common denominator is 24, but I was also told another common denominator is 48. To get a common denominator, you can always just multiply the denominators together. And that's what you're going to do a lot of times when you have a lot of x's on bottom. Or y's, or whatever letters. Your common denominator is just going to be multiply your denominators together. Yes, in fact, we're going to leave it factored. So I'm going to write this as x minus 2 times x plus 3. We almost always leave things factored, hoping that maybe we'll get lucky and something will factor on top and we'll be able to reduce. So you don't need to do FOIL down on bottom here. Leave it that way. Leave it in the factored form. It's better to leave it that way. All right, so the first fraction. What did I multiply the bottom by? So I need to multiply the top by x plus 3. I'm just going to leave it here for a minute. 5x times x plus 3. And then in a second, I'll do the distributing, and then we'll combine all our like terms. Second fraction, I went from an x plus 3 to this thing. So what did I do to the bottom? I put in an x minus 2. So I need a 27 here, 27x, and then an x minus 2. All right, so a very common mistake people make is they say, well, I can reduce this x plus 3 with that x plus 3, and I can reduce that x minus 2 with that x minus 2, which is correct. It puts you right back where you started, though, doesn't it? So you do not want to reduce at this point, because if you reduce, then you no longer have a common denominator, and all the work you just did, you just erased. And then you can do it again, and reduce it again, and do it again, and reduce it again, and you're there forever. So don't do that. What you want to do is up on top distribute. So that's 5x squared plus 15x plus 27x minus, or 27x squared minus 54x. So do the distributing up on top, add things together, and leave the bottom alone. X minus 2, x plus 3. And so my final answer, I combine the like terms. 32x squared minus 39x over x minus 2x plus 3. Now, it is a good idea to see if you can factor the top and see if anything's going to reduce. I don't think it will either. On top, I can factor, I can take an x out. But that's it. Nothing's going to reduce with an x minus 2 or an x plus 3. So again, I would just leave it just like that. I wouldn't even bother factoring the x out. I can see I can do it, but it's not going to do me any good. Questions on that? How is subtracting fractions different? They're more annoying? He has a point. I'll agree. The biggest thing is you're going to watch for that minus sign, don't you? That's the easy thing to screw up. All right, so let's say I gave you. Start off easy? All right. How easy? Real easy. All right. 4 over 3y minus y plus 2 over 6y squared.
Well, I mean,
Just great. I agree. It's a great problem. I just made it up off the top of my head. So you like 12y squared? How about just 6y squared? You don't like that? You like 12y squared. Okay. You can use 12y squared if you choose. But I would go with 6y squared. Again, I would always go with the smallest common denominator. So I notice if I take this one and multiply it by a 2y, it gives me the 6y squared. So I think my common denominator is going to be 6y squared. Which means I don't need to do anything to that second one. It already had the common denominator. That makes my life a little bit easier. 4 times 2y, that sounds like 8y. All right, so 7y, say that again. Minus 2 or plus 2? Yes. Which one? Why is it minus? Because I need to take this minus sign right here and distribute it through. So there's the biggest difference with subtraction, and there's the biggest mistake people make. You've got to take this minus sign and distribute it through this numerator over here. The most common mistake here, people will write 7y plus 2. It really needs to be 7y minus 2. So watch out for that. That's the biggest difference in adding and subtracting, is you've always got to remember to distribute that minus sign. And it's easy to forget. It's easy to forget to distribute that minus sign. So watch for that. Okay. All right. How about a really hard one? Oh, you asked for it. All right. X plus 2 over x squared minus 16 minus 3x plus 1 over x squared minus 7x plus 12. There we go. There's a good one. Thoughts on where to begin? Factor the bottom. It's always a good idea. All right. So how does x squared minus 16 factor? X plus 4 and x minus 4. How does x squared minus 7x plus 12 factor? Somehow x minus 4 and x minus 3. Okay. So what's my common denominator? Well, that's right. It needs I need to have an x plus 4 and an x minus 4 for this first fraction. The second fraction says I need an x minus 4, but I already have one, don't I? I don't need to repeat it. It's kind of like, again, going back to here, 8 times 6 would give me 48, but that's not always the smallest one, because these already have a 2 in common. This is 4 times 2, this is 3 times 2. I don't need the 2 multiple times. All right, so my common denominator, the first fraction needs an x plus 4 and an x minus 4. The second fraction needs an x minus 4. I already got one. And it needs a x minus 3. So there's my common denominator. X plus 4, x minus 4, and x minus 3. Should have left more space here. X plus 4, x minus 4, and x minus 3. All right, so the denominator is going to have 3 pieces like that also. Okay, my first fraction. My first fraction already had an x plus 2 on top. And then I added an x minus 3 down on the bottom. So if I put an x minus 3 on bottom, I need an x minus 3 on top. So I put an x minus 3 there. Second fraction had a 3x plus 1 up on top to begin with. And the new thing I put down on bottom is an x plus 4, so I need to put one of those x plus 4s up on top. All right, equals. Again, we're not going to do anything at all to the bottoms here. We're going to leave them. We're going to leave them factored. So we write it as x plus 4, x minus 4, x minus 3. X plus 4, x minus 4, x minus 3. Up on top, we're going to do FOIL here. We're going to do FOIL there. And then finally, we'll combine all of our like terms in the end. All right, so I FOIL here. I get x squared minus 3x plus 2x minus 6 minus FOIL there. I have 3x squared plus 12x plus x plus 4. Final answer. I have x plus 4, x minus 4, and x minus 3 on bottom. Up on top, I have x squared minus 3x squared. That sounds like negative 2x squared. All right, now we're going to watch our minuses very, very carefully. Minus 3x plus x. That's negative x. Over here, I have a 12x and a 1x. That makes a 13x. But again, I need to remember to distribute. So this is a minus x minus 13x. So it's minus 14x. That's right. Again, that's the biggest mistake right here. Make sure when you combine these, you get a minus x. When you combine these, you have a 13x, but you're subtracting negative x minus 13x is minus 14x. And then same deal here, minus 6 minus 4, negative 10. Questions on that one? Would I? Yes, I probably would. What would I probably do? I would probably try factoring that top to see if something will reduce out. So I think you're right. I would. You should. I mean, we always write our fractions in lowest form, right? All right, so how can I factor that top? Not only can I should take a negative 2 out. That leaves me with x squared plus 7x plus 5 all over x plus 4, x minus 4, x minus 3. Unfortunately, I think x squared plus 7x plus 5 is prime. So unfortunately, I can't factor anymore, so unfortunately, nothing reduces. It should accept either. If it doesn't, if you type one in and you're pretty sure you have it right and it marks it wrong, send me an email and I can go in and I can look at it. And if the computer's not set up to grade it correctly, I can change the grade. It's easy for me to do. Other questions? If I wanted to be really, really mean and make it even harder, I'm not thinking word problems even. Multiple variables would make it slightly harder, maybe. That would make it a lot harder. I was thinking to make it harder, I'm not going to do this to you, so don't panic. I could make these things harder to factor, couldn't I? For example, if I gave you 2x squared minus 7x minus plus 12, then they're harder to factor. So that's really what I can do to make these harder, is make the factoring harder. But I'm not going to do that to you right now. Right now. Yeah, try to be nice every now. Because we have one more thing to talk about today in this section. And that's called complex fractions. That sounds like an oxymoron, doesn't it? Aren't fractions complex enough already? It's like Happy Monday, correct. Yeah, sounds like an oxymoron. Anybody know what a complex fraction is? What makes it complex? Complexity. All right, so a complex fraction would look like something like this. 1/2 plus 1/3 divided by 1/4 minus 1/12. So that's known as a complex fraction, also sometimes called a repeated fraction. Because it's got a big fraction bar, and then up on top you got fractions, and down on the bottom you got even more fractions. So that's typically known as a complex fraction. Fractions involve your fractions. So that's exactly what we're going to do. What we're going to do is we're going to split it. We're going to do the top, so we'll add those fractions together. Then we're going to do the bottom. We'll subtract those fractions. And then finally, at the end, we'll do the divide. We'll flip and multiply. That's exactly right. All right. So we split it into two parts. 1/2 plus 1/3. Who's your common denominator? 6. Okay. The first fraction becomes 3/6. The second fraction becomes 2/6. So the top is 5/6. All right, so that's what I like to do. I like to do everything up on top first. Then I go to the bottom. 12 is the common denominator. So that's 3/12 minus 1/12. So that's 2/12. All right. Now I have just a fraction divided by a fraction. Take a fraction divided by a fraction. I could also reduce to 2/12 before I flip it. And then you'll have common denominators. Okay. So that's 5/6 times 6/1. Because I reduced my 2/12. I thought of it as 1/6. I flip and multiply. Final answer is 5. That 6 reduces with that 6. Now we got to throw in some x's. That's right. But the idea is exactly the same. Why? Because it's Monday. That's right. That's right. The weekend is over. Welcome to complex fractions. All right. So how about 1 over x minus y? You've been asking for more variables. Here you go. Plus 1 over x plus y divided by 2 over x plus 3 over x plus y. Gruesome. All right, well, again, we start with just the top. Looking at just the top, what do you have for a common denominator for me? X minus y and x plus y. We just multiply them together. No common factors. All right, so we're going to have equals. We're going to have x minus y and x plus y. Plus another one, x minus y and x plus y. All right. First fraction. What new thing did I put down on the bottom? The first x plus y was a new thing on bottom, so I put an x plus y on top. Second fraction, what new thing showed up on the bottom? So I'll put an x minus y up on the top. All right, so this equals, clean up my whole numerator first, 2x over x minus y, x plus y. X plus x is 2x, the y's add up to 0. Alright, so there's everything up on top, done first. Now we jump to the bottom. Yep. Common denominator down on the bottom. X times x plus y. Okay. X times x plus y plus x times x plus y Alright, first one had a 2 up on top. Who's the new thing on bottom? X plus y, so put that thing there. And then the second fraction, it had a 3 up on top to begin with. 3x. Alright, so this one looks like 2x plus 3x is 5x plus 2y over x times x plus y. We flip and multiply, and some stuff is going to cancel out. That's right. So we have 2x over x minus y, x plus y, times x plus y over 5x plus 2y. We flip and multiply. That x plus y reduces with that x plus y, and unfortunately I think that's a... Well, they're both on top, so I multiply them together, I get 2x squared. But they don't reduce, do they? Unfortunately. Final answer, it looks like 2x squared over x minus y times 5x plus 2y. Questions? Alright, that was such a fun problem, I'm going to do it again. One over x minus y plus 1 over x plus y over 2 over x plus 3 over x plus y. This is the way your book teaches you to deal with complex fractions. The way the book says is add the stuff on top, add the stuff on bottom, and then flip and multiply. When I learned how to do this many years ago, I learned a different way. How many was it? I don't remember. It was a long time ago back when. I do remember when Texas Instruments came out with graphing calculators. Yeah, I remember that. All right. Here's the way I was taught to simplify these complex fractions. What I was told to do is look at all the fractions at the same time, there's 4 of them, and find the common denominator for all 4 things. So I see I need an x minus y, I need a x plus y, I need an x plus y, I already said that, so I don't need it again, and then I need a x. So my common denominator for everything all at the same time would be an x minus y, an x plus y, and an x. Okay, so I find all 3 common denominators at the same time. No, I don't flip it and multiply. What I do is I take every single piece and I multiply it by that common denominator. And I agree, it looks gruesome at the beginning. But it gets really good really fast. Because what happens with this x minus y down on the bottom when I multiply it by this thing? It reduces, doesn't it? So this x minus y reduces with that x minus y, and I'm left with x times x plus y. Plus, what happens when I take this next fraction, 1 over x plus y, and I multiply it by this whole thing? The x plus y's reduce out. And I'm left with x times x minus y. Down on bottom, that x goes with that x. So I have 2 times x minus y, x plus y, plus, and then finally, that goes with that. I'm left with 3x times x minus y. It gets rid of the fractions in one step. It gets rid of the fact that I have double fractions all at once. Now it's not so bad. I distribute, I combine my like terms, and I see if I can factor and cancel anything out. And then I'm done. All right, so this is going to become x squared plus xy plus x squared minus xy over, now the bottom's not so nice, but it's 2x squared minus 2y squared, because I notice these two are conjugates. When I FOIL them out, the middle two pieces go away. And then this one is plus 3x squared minus 3xy. And so my final answer. Those reduce out. I have 2x squared up on top. Down on bottom, I have 5x squared. I'm going to write it this way, minus 3xy minus 2y squared. We usually kind of put them in alphabetical order like that. The only question is that the same answer I got before? Ish. This bottom is the unfactored version of that bottom. Did I get the same answer? Yes? Which way is easier? Well, that's up to you. My opinion is this way is easier. There's less steps. There's also less writing, I think. You don't have to deal with all the fractions. It's still quite a bit of work. Don't get me wrong. Yep. Yeah. You should factor that out just to see if anything's going to reduce. But my opinion is that's the easier way. When you go to take your take-home quiz, or you go to take your test, and you're simplifying these fractions, which way should you do it? It doesn't matter to me. Whichever way works better for you is the way you should do it. Some students really like this first way because they really like, all right, we just did a whole bunch of adding fractions. I'm really good with that, so I'll add those fractions. And then I'll add those fractions. And then flipping and multiplying isn't so bad. So some students do prefer this way. If you prefer that way, please do it that way, if that's the way that works better for you. It really doesn't matter to me. But again, this is the way I was taught. To me, this way is quicker and easier, so that's the way I tend to do it. I did it the other way today first because that's the way your book does it. If you're looking at your book, that's what you're going to see.